Hello. Good morning, everyone. Thank you for giving me a chance to present in here, and thanks for the introduction. I'd like to give you an overview about how we see 3D printing, additive manufacturing. Terry Hullers just said everything is fine in the industry rather than share prices. I fully can agree with this. Our share prices dropped significantly post-IPO. I think it's very typical for new technologies that people are at the very beginning are very ambitious and over time they can't await the changes. But we saw this in the internet hype, and I think in 2003 or 2004 everybody thought about, is internet valuable? Today everybody knows it is, and it will be the same with additive manufacturing. What is 3D printing? The hype was driven a lot on the consumer market. Everybody knows the printers for $1,000, and everybody thought all of us will have printers at home and print our goods. I think in the meantime, most of us recognized that the only thing you can print with those little printers is toys you don't need. I don't know what you say about it, but it's probably, it won't, it's not an industrial application, and I think the industry will be driven on large format printers like those printers, where we really can compete against conventional tooling. Nobody is interested in, if you talk to clients, whether that product is made out of conventional tooling processes or out of additive manufacturing. The main driver is what does it cost and what is the product behavior. And that is what all of us partly struggle still a bit in additive manufacturing, because the behavior of whether it's laser sintered or in our process is a powder binder process, you create a composite material with certain disadvantages. And so all of us have to identify markets where we can make use out of those disadvantages. And what we do is, before I just show you a quick movie on how our process is working, before I step into applications.
Phenolic direct binding is a new 3D printing process developed by VoxelJet. Its main benefits are untreated particulate material is used. Material is 100% recyclable. Increased strength for better results in metal casting. We will now explain the PDB process based on our VX1000 system. As usual with the VoxelJet 3D printing process, the job box in which the spring molds are printed later on is loaded. First, we upload the CAD data before the printing process begins with the recoater and infrared radiation. Next, the binder is applied. The animation illustrates the printing process. The particulate material is applied by the recoater without being pre-treated. An infrared lamp preheats the build space to speed up the hardening process. A short time later, the film resin binder is applied only to the places where we want the component to be printed. Combined with the film resin binder, the infrared radiation maximizes material strength. This process continues until the component is finished. The loose, unprinted particulate material can be removed easily. Up to 100% of the unprinted particulate material can be reused. The high material strength further improves handling for metal casting processing. Learn how VoxelJet can help you optimize production.
So as said, the behavior of printed parts is in many cases a composite material, and we, for example, try to identify vertical markets where we can grow into and where we can make use of that. And metal casting, for example, is a very interesting market for us, where those disadvantages of having a composite material created really benefit. If you look into the overall additive manufacturing methods, laser-based, printhead-based, I'm sure all of you know them and know the advantages and disadvantages. Currently, everybody in the industry, and we saw this through the 2 acquisitions, which maybe some of you recognize, that GE bought Concept Laser, bought Arcam, tried to buy SLM. I think that didn't happen. But everybody is interested in real parts, means that you have a 3D file, send it to the printer, and going to get out a part. That still is very, very tricky. You have a lot of applications on metal laser-based pieces, but all those pieces are still very small. And if you talk about high volume, you still struggle. And I think on the long run, what the industry really needs is large format printers where you really can print high volume, high throughput, even with bigger parts. And you said it, you mentioned heavy equipment supplier. So if you a heavy equipment supplier, if you just imagine you want to cast an engine block or gearbox or impellers, you won't do this on a built-in block like this. So if you create a tool or whatever in that vertical market. And we dived into that. We see a lot of interesting opportunities, but as well, what we see is that the issue we have is always with the binder supplier, with the powder supplier, and with the behavior of the material. So we're growing into, but we as well have a lot of challenges still in the market to convince clients in investing in additive manufacturing on a larger scale. And I fully agree with you. It will grow. All of us will grow into, but it will take a while. It won't happen within 2-3 years. It will take 5-10 years. We're working on projects with large automotive suppliers to substitute core shooting machines. Those projects start in 2021. So it's still a long way to go. But there's with no doubt, additive manufacturing really will grow into manufacturing processes, but it won't substitute all existing processes. It's another technology. It's an add-on. It's an add-on which will be used with lower quantities, high complexity. Talk about the benefits of additive manufacturing. 3D problem solved by 2D layer-based process, freedom of design, no complexity constraints, production costs per part, independent from lot size, fully automated sample to operate, integrated database, full control of production time and spot. What can it be used for? Overall, what we saw over time, over the last 16, 17 years since we managed it, and that didn't change, production costs depend on volume and complexity. Those 2 drivers still trigger a piece. And with additive manufacturing technologies, you really can, you are in a position to create goods and engineer them in a much better way. Applications are architecture, art design, consumer goods, medical, you name it, catalyst production. But again, the main questions with clients are always material behavior, strengths, surface. Surface is especially in our process, a strong discussion, but as well on laser-based processes. If you use laser-based processes, you still have in mind you have a powder, and the surface is not like if you have used a milling machine. Fast-growing market. I hope, Terry, those numbers are right. It's your numbers. Just checked it. But the global manufacturing market in 2015 was 12.8 trillion. Global additive manufacturing market in 2015 was 5.2 billion. And the current additive manufacturing market represents less than 1% market share. And even if it presents a 5% market shares, it's a significant growth over the next couple of years. But again, it won't happen within years. It will take decades until we see that growth. What all of us are working on is to make printers more reliable and increase the performance. That's where we a lot work on through improvements, and that's probably good. That's a good example of traditional metal casting processes. You see, timing is a main driver currently, and if you have high complex pieces, you even can't do them. With a technology where if it's additive manufacturing, you really solve the pattern production. You step right out of the scanning, either scanning or CAD design, into a pre-processing, preparing the data set for being used in a printer. You print your mold and you cast. It's a significant time saving, and that includes cost saving. I think that's about us. Our process. I think that's designed for manufacturing solutions. I think this is a pretty good example how additive manufacturing can improve products, especially if you see, like here, undercuts, etc. Say 87-gram weight savings per piece. What does it drive us? So there's a high interest in every industry to optimize design, if there's innovation, to use production methods where you really can benefit from the innovation other than waiting for. Here's a calculation example of a water jacket core. That's probably the most complex part in a casting process, and this is where we currently still struggling. We see a ratio of 1 to 9. So a piece conventionally manufactured costs approximately €4 based on a tooling cost of 30k euro. So if you have a huge production, you still can't compete. Our piece still costs €35 on a large format printer. But we came over the last years, we came a lot closer, and currently we really know where we have to improve our printers, where we have to make them faster or platforms bigger to achieve that ratio. And the projects we currently working on with the automotive industry, where we try to substitute core shooting machines, we reached that level already. Here's a calculation of a water jacket core. It's 90,000 printed parts a year, so that is real production. So there are additive manufacturing solutions in the market who could match the demand. Question always is accuracy, green strength, and so on. There's another movie to show you. I'd like to show you. That's VX4000. And even those printers are, for certain applications in the industry, too small. They have to become bigger.
Its key benefits: the combination of mold and core production of different sizes increases productivity for greater flexibility and cost efficiency. The build process begins by moving the building platform into the machine and uploading CAD data. The coater is filled with particulate material and applies a precise layer of sand onto the building platform. The print head then selectively prints the binder. Each time a layer is finished, the coater adds print head rise by 1 layer thickness, and the printing process continues until the components are finished. Due to the large build volume, stable sidewalls are printed layer by layer as well. They have to be removed along with the unprinted particulate material during unpacking. Learn about possible applications and how VoxelJet can optimize your production.
In that movie, you saw a lot of steps where we need improvement, unloading where we need robots who help us to really optimize the work stream. And there's a lot of work still in front of us. software is not good enough, the software we're going to work on doesn't give us data sets where we have real accuracy, where we can print parts with a high accuracy if we scale them. Material suppliers, binder suppliers. In a simple issue, we inject a binder through an average size of a nozzle of 25 micron, and that's a glue. So everybody knows what it means if you inject a glue through such a thin layer, it's clocking. To get a binder quality where the supplier reduced or filtered the binder to a rest content of particulate material of 2 micron is quite tough. The volume additive manufacturing suppliers buy is still not big enough that you have a lot of suppliers available, and you really depend on 2-3 suppliers. Again, what I want to say is we are heading the right directions. We achieving pretty good results to really see the market adapting it even quicker in production. Means as well that the suppliers, material, software suppliers, robotic suppliers help us, and at least, last but not least, the end user has to take some risk. Okay, we're still struggling because I think the acquisition GE made was a great signal to the market, but other industries still don't invest enough money in additive manufacturing and take the risk and train and take their lessons. Good, that was it from my side. Thank you for listening.